Hi, this is Presh Talwalkar. What is the integral of sine x cosine x? Let's try and solve this perplexing integral. One method of attack is to do a u substitution where u equals sine x. du equals cosine x, and we end up with the integral of u du. This becomes 1/2 u squared plus an arbitrary constant. Substituting back in for u, we get the answer sine squared x over 2 plus an arbitrary constant. But that's not the only way we could solve this problem. We could have also done a u substitution where u equals cosine x. In that case, du would equal negative sine x, and we end up with the integral of negative u du. Simplifying this answer, we end up with the result of negative cosine squared divided by 2 plus an arbitrary constant. This answer is different, but we can even solve the integral in a third way. There is a double angle identity that sine 2x equals 2 sine x cosine x. This means our integral is equivalent to 1/2 sine 2x. Simplifying, we get a result of negative 1/4 cosine 2x plus an arbitrary constant. So now we have a very interesting result. We have 3 different ways that we've written the answer of the integral sine x cosine x. And they don't look anything like each other. So how is this possible? How do we have 3 different answers when we solve this problem in seemingly valid ways? There is a reason for this. We can look at the graph of our 3 results, and we can notice that the 3 graphs, the functions of these graphs, only differ by a constant amount vertically. Since antiderivatives are defined only up to a constant, this demonstrates that these graphs are all corresponding to the same antiderivative. Because they only differ by a constant, and each antiderivative you add an arbitrary constant, this shows that each of our solution, all of these 3 solutions are equivalent to each other as antiderivatives. But we can also prove this directly. So let's show that these 2 solutions are equivalent, that they only differ by a constant. We'll use the trigonometric identity that sine squared x plus cosine squared x equals 1. We'll solve for sine squared x, and then we'll substitute into the first solution. We end up with the result of 1 minus cosine squared x over 2 plus an arbitrary constant. And this simplifies to negative cosine squared x over 2 plus 1/2 plus an arbitrary constant. Here's what we can simplify. 1/2 plus an arbitrary constant is still an arbitrary constant. So we can lump these terms together to an arbitrary constant. And thus we found out that these 2 solutions differ only by 1/2. They differ by the constant of 1/2, and therefore they are the same equivalent antiderivatives. Let's do the same thing. Let's show this third solution is equivalent to the second solution. We'll use the cosine double angle identity that cosine 2x equals 2 cosine squared x minus 1. We'll substitute that into our third solution, and then we'll simplify to get, again, negative cosine squared x over 2 plus 1/4 plus an arbitrary constant. So this shows the second and third solutions differ only by the constant of 1/4. Therefore, they're equivalent to each other because we can group the arbitrary constants together. Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like the video, please check out my books. There's links in the video description.